Yeah. So yeah, thank you. But I'll consider that. Okay. So I'll walk around. Thank you. And I hope all of you guys can see it. And you can put it on gallery view. Okay. So I think that'll be much better. And let's also make sure it's recording. Oh, it's probably already recording. Hey, wow. Okay, we got a lot of students here. Okay, multiple screens and all. All right. Well, thank you guys for showing up, and hopefully it's being recorded all the way. So the audio will, pick up at some point, I think. But anyway, the important thing to be said, which really is that I know that every one of you is actually capable, right? Don't mind that we're not covering programming today in class, okay? All of what we're going to cover today, especially since, data manipulation, data representation, you're already looking at that stuff. And you're going to be working on problems in data representation, or asking questions each other in half hour or an hour, and we'll have that going. But this preparatory work is super duper important because it applies all the way through CS2A. If you want to do my 2B and 2C, where it works all the way through. And our tutors in the STEM Center may not be trained to not give you answers, but Chris is, I think, okay? Because I've seen his answers and posts on comments on Reddit, and many times I have had to tell other people, don't give the answer away. I've never had to tell you that. Yes? Yeah, great. Okay. So because the reason I say that is because there's a pleasure in finding the answer. Okay. And many times teachers just take it away by telling you what needs to be done. Okay. But finding that will take you a lot of time and effort, and lots of people just give up. Okay. And I think, and I was just actually telling someone else earlier today that ultimately it just boils down to blind faith. But a blind faith of a certain kind, not just blind faith and green goblins out there, invisible green goblins, but really blind faith that says, I'm going to do something irrational, right? Because no sane man would do something irrational. This is irrational because I know everything tells me that I cannot do it, right? But I'm still going to do it because I believe in something, okay? And you can call that belief anything you want. You can call it God, I'm doing it because God commanded me. Or you say, I believe in myself because I have the power to do it. And I've not been doing it just because. Just because. And you don't know what to fill in after that. Yes. So then that means that everybody can do it, but they have to apply themselves to it. And this is going to be a hard course, I can tell you that right away. And this is actually one of the easy first lectures, okay? Because once you start questing, once you start coding, it'll actually be fun. And it'll be challenging and fun. But the important thing is that you have to plan your other courses very carefully around this, okay? There are a lot of people who just say, well, you want to pick up a CS2A or in computer science on the side, doing other things. Okay, that will give you an appreciation. If you do it properly, it'll give you an appreciation of why computer science is cool and hard at the same time for most people, okay? But it won't get you past that, well, it's hard, but can I get it? Yeah, okay, so in order to say it's hard, and I actually do manage to get over it, I can see why it's hard, and I can also help people that find it hard, okay? But then you actually understand subject. And that requires extra dedication. And it's just like music practice or anything, right? So many days you just say, well, I've tried it a million times today, and it just doesn't work. My fingers don't move like that at all. Maybe, I have a muscular genetic issue, right? And you may say, hey, come on in. Actually, yeah, thank you. Thank you for coming, okay? Yeah, you should absolutely attend all of these classes too. Yeah, he is in CS2B. But he missed a bunch of the blue busts, so I asked him to come into class and work with. Because we have a lot of help here, Chris, Panani, he hasn't done the bust, but I think he'll be able to help you because he knows not to give the answer away. The same as the questing, the cloud class. So no answers to be given, but you help people in the right way. So there's lots of people that will help. So yeah, thanks for coming. So I was saying, yeah, so you just need to believe in yourself against all odds, okay? So that's an irrational belief, but you have to do it. And if you do that and commit to it, I have to commit to it and stick with it and say, well, I'm going to do it at the cost of things, right? Maybe I'm going to not play, less Fortnite or, socialize less, but I'm going to do this. And so what is the return you get? The return you get will not be seen until after you finish 2C, which is a red level. Okay, after you finish the red level, ask Chris and other people who've done it. After 2C, you will actually feel independent. Okay, that is the root thing that in education is driving towards. Okay, it's not towards telling you, well, this is what happened in 1845, and this is the recipe for making dental floss. Right? No, that is not education. The education is basically making you self-sufficient. To say that I can live even if I lose everything else in this world, right? Because I know. And a lot of people don't do that because they just, well, this is a community college course and, get it done. So you just have to shake that attitude off. And I think in the Bay Area, because, a lot of people are being pushed to do classes, which they are not naturally interested in. But even if you're not naturally interested in it, apply yourself, okay? And I'm pretty sure that you will find by the middle of 2B, right? Until then, you may have to push yourself, saying, well, I don't know if this is going to be fun, but someone told me it's going to be fun, okay? Someone told me it's going to be fun. Eventually, it's going to get fun. Eventually, I'm going to do it, okay? So you got to believe that. And it's I don't know, I can't give you empirical evidence beyond, historical data, right? So, but you got to believe that. And if you do believe that and work through this thing, and I can guarantee that if you complete if you're dog red, okay, here it is, okay, if you dog red and still don't feel a sense of accomplishment and a confidence that you can basically take on the world, meaning that I can go out there, I can do random coding interviews. Doesn't matter. Even if I don't get the job, I would have got a great experience out of it because it's an interesting problem. Two people or more people had a chance to look at together. Yeah. So that kind of attitude, instead of, oh my gosh, I got late code, crunch lead code today, right? That kind of, you won't feel like that. You'd actually look forward to this as tasty treats. And so if you don't feel like that at the end, you should actually let me know. And I've actually waged money for it. Maybe I'll give you $1,000, okay? To complete red and send me an email saying, I did red and I dogged it. Okay, I dogged red, but I don't feel that sense of accomplishment as a computer scientist, okay? Not just C++ programmer, okay? Because C++ is just a language, right? A language is a medium to convey thought, yes? Because, language by itself is empty. But when you inject semantics into it, there's thought behind the language. And that is essentially what goes from my mind to your mind, not the language. I could be teaching in Chinese, right? Indonesian. I could be teaching in any language, but it's exactly the same material. So it's just like computer science too, right? So we are using C++ to learn about concepts in computer science. That's all, okay? So lots of people make a big thing about, oh, it's Java, Python, computer. See, that's not bullshit, okay? At the end of the day, they're all just means to look at this whole thing. Whether you look at it this way or that way, it's the same thing. But the thing is, the cool thing about anything that you set out to master is that you do need a lot of different perspectives of the object to get a holistic view, right? If you just look at a sphere, for example, if you look at it one side, you're going to get a one picture, one side, one side of the moon or the other side of the moon, whatever. They got the space thing now, right? Moon stuff, moon people there, moon robots there. Yeah. So yeah, one side is never visible, right? So it's like that. In order to get you got to get multiple multiple views, so that in your mind, the neural net in your mind can reconstruct using just points, right? Using just points, it can reconstruct a 3D picture. Yeah. Because I was thinking about this because I got this incredible, interesting vine in my garden. It's a plant, and I've been watching it over several months. And interestingly, I'm looking at it, I'm thinking it actually seems to know the exact shape of a pole and it's of a branch around it. Okay, it's near it, not its own branch, some other branch is near it, but it seems to know. Well, not like in a metaphysical sense. And I thought, how is it possible? Right? How is it possible that because it sends shoots and other things in the right direction, okay, not colliding in. So and I thought, well, how could it possibly do that? And if you think about it, every time the wind blows and it hits against this branch, it gets one data point. Yes. And so you could just build up over millions and millions of these hits, a very good shape, right, in your mind that models where the branch would be, which is exactly what we're doing with photons and real things. Yes. Because we don't know what the real shape of that bottle is, right? It's a Swedish bottle. Maybe it's like, right? Okay, so but we say, oh, photons bounce off that and it's my eye, and we just reconstruct that shape. That's what it looks like. And plants have, if you can model it like that, I guess. Anyway, so the point, I don't know how we got started talking about that. But basically, yes, yeah, different perspectives on the problem. So once you are really solid on computer science, not in C++, okay? C++ is one language you need to learn perfectly in order to appreciate computer science through C++. Okay, and really, if you take the CS2A 2B series, only 2A really focus on C++. Okay, starting in 2B, it doesn't really matter which language you do it in. It's all pretty much it's concepts and data structures. You're playing with stuff in memory. And a lot of it looks intimidating now, but when you actually step through sequentially the code, the quest in blue, you'll find that green one, green two, green three, they'll naturally follow one after another, right? You won't feel like, oh my, you won't feel intimidated by overwhelmed by any of these quests, as long as we do it in sequence. And most of the time, I found that people who get overwhelmed are usually, right? This is when you manage engineers, the engineers who get overwhelmed are usually the engineers who basically try to overstep, meaning they try to bite more than they can chew off, right? Or bite off more than they can chew, right? And then it leads to races in your mind and saying, how am I going to complete that? All these, but just take the right amount of step at each time. But that takes practice, right? Taking the measured gaps, and that is the reason why I love the sequence of topics that we have chosen for CS2A. And by the way, I didn't come up with these topics myself. Not all of them, right? So I came with some of them, but a large number of these topics came from Michael Losa, who was a previous CS prof at Foothill, and he wrote a bunch of modules. Someone posted on Reddit saying, "Hey, is there any reading material? How do I do Hello World?" I posted on someone posted on Reddit. Anyway, so he wrote the modules. You should absolutely refer to the modules. There's a link to the modules, and Chris probably knows. You can talk to them later. So the topics that Michael chose are just right. Okay, that is why it's like super duper important. When you do this class, do it all the way to red, and focus on the topics in the modules and the quests which have been chosen, so that there will be, you have to struggle, but you'll make it. You won't fall in the water. So it'll be like, hops you can make, and by the time you're there, you'll actually know. You can go back and forth, right? Once you can play a scale, you can just go back and forth, yeah, like that. But getting that, getting in the rhythm, I think blue is very good. So I'm glad you enrolled in this. And I think the bootcamp is a really cool experience because, I wasn't planning on offering the bootcamp, as Chris knows before. But the thing is, I wasn't planning on offering 2C either. The level. So I thought, I'm not getting good students in 2C because most of the students in 2C are after the grade. They're not really after learning, and it's really hard to teach hard topics to someone who's just after grade. And so I said, I'm not going to offer 2C. But then, a bunch of students emailed me who were really interested. Not, but there's only a minority. So I can't run a whole section for that. I can ask Foothill saying, well, there's 10 students interested in this class. So open a new section. It doesn't make, financial sense for Foothill to do a class for 10 students. But they can get like 40 students, but 30 of those students will be grade seekers. And I don't want to teach them. So this is a conundrum. And so I decided not to teach 2C, but I am teaching 2C because of, special request. But when I decided not to do that, lots of students emailed me saying, how, what do I do after 2B? And then I said, the fact that I'm not teaching 2C doesn't mean you don't have to class. You either go on and do the red class anyway, because it's all free, right? It's just that you won't have any formal classes. Not that we had any formal classes in 2B and 2C, right? It was just student meetings. That's when it occurred to me. One time when I was coming back on a bus from Foothill it's actually, the story is recorded on one of the YouTube videos. So coming back on a bus from Foothill to my home over Dumbarton, I saw a flyer for a boot camp somewhere, right? I thought, and then I started remembering all of the email that people had sent me before saying, I enrolled in this boot camp. It didn't help me. It's 25K, 50K, and spending a lot of money on boot camps and so on and so forth. I said, why is this a total waste? People should be they should be able to learn if they want to without having to shell out that much money. And then I thought more about it. And when I came back, I thought, let's get a bunch of interns at Nonlinear Media and create the website and the Genius Bootcamp. Chris, Namrata, Dylan, Oliver, Chow, those guys basically put together the whole thing. It's really, really cool. I like it. And when you enroll in it, you go all the way from blue, green, and red. I'll help out every way, everywhere I can, at bootcamp. And I'll stay with it as long as it, has good momentum so that it's self-sustaining. So that the seniors help the juniors and it's just going by itself without my conscious or anyone's conscious involvement. So that is the goal with that bootcamp. Hopefully you'll all continue, right? All the way through. That's basically it. I didn't mean to take up so much of your time. Hey, welcome. What is your name? Roger. Are you enrolled already?
Enrolled, yes.
You are. So yeah, actually, that's the name that I don't recognize in the roster. Okay, Roger. I'll get to know all of you in Zoom. It's strangely enough, I do remember most of your names now, but over Zoom it actually kind of clicks more in your head. After I've seen you in Zoom once, it's just I can just remember. But after 2 or 3 classes, I'll probably remember all your names. Okay, so if you have any other questions, I'm happy to answer them. Otherwise, what we'll do is 6:20. Oh my God, this class is like 6 o'clock to 7:50, right? Yeah. Okay, so we got a lot of time. Maybe I'm talking really fast. And it looks like we covered a lot of ground, right? Or to me, it seems like I covered a lot of ground. Did we cover a lot of ground? No, right? We had barely started talking about data representation and all. Yeah. So, all right. So how about this? Anybody who has, like, unless you want to talk to me or ask me questions that I can answer about the course, right? Let's use the rest of the time to essentially form disciplined, civil, good groups of people that are also flexible and fluid. So you can move from one group to another and all, right? 5 or 6 groups, right? And then you're talking about different topics in data representation. And if a bunch of people want to understand a particular concept, you can either just say, hey, why don't we ask the prof to do it on the way? Use whiteboard. Is there any part of the whiteboard we can use?
I think it is, yeah.
Yeah, okay, so we got some space. Some space. But this is just a last resort, right? It's just last resort. And but most of the time, you guys will be helping each other out. If you're absolutely stuck, I'll just come by and help. Chris can help. I'm pretty sure Anani may be able to help me with most of these things. Okay. And Simon, you may also actually be able to help with a lot of data representation stuff because that was very similar to some of the stuff we did in other classes. Okay, so that's basically it. So I don't have anything special to say unless you have something to ask me. Otherwise, we'll just go ahead, get into our groups, talk to each other, maybe even just introduce yourself in the little groups and wander around. Just make sure to not mess up the thing, like I said. I don't see how people can actually mess up so much. But this looks like a regular class. This is how my class used to look. Oh no, the tables were all right direction. Okay. All right, okay, so we have idea how they're all equal signs. Okay, all the tables are equal signs. Great. Okay, you don't have any questions for me? Otherwise, you just go ahead, talk about data representation. The important things about data representation, really. If you want me to talk about data representation, I'm happy to talk about them. If you want to talk, maybe talk about information theory, right? It's like super duper interesting subject, okay? So everything is really interesting. But information is one of the really I don't know how to characterize it. Maybe I don't have a characterization. It is an interesting topic. Okay, it's interesting because what we're trying to get at is can we actually quantize information? Because everything else we buy, everything we do is quantized. Really, we live in a discrete world, a digital world, right? Everything is We can't deal with continuous quantities unless you quantize them and deal with packets. Yeah, even photons, right? However, information. But can you actually buy information? Okay, or if you buy information, can you say this is more than that? Do you have a comparator for information? So that is an interesting question, isn't it? But you can develop an entire science around it because all you need is some kind of way in which you can represent information. If you can come up with a way in which you can represent information, let's just say discrete information, right? You can come up with a way to represent discrete information. Then you can play with lots and lots of ways in which you can manipulate the representation and change information from one form to another. That's all it is, right? All of computer science is basically about how to represent information and how to change that representation from one form to another. Okay. That's all we're going to do in different guises and different forms. And as we work through projects, and we're going to be doing this live on Zoom, right? People will be coding. You'll actually see this in action, right? We'll just basically start off with bits and bytes. Everything is bits and bytes because ultimately, if you want to look at information itself, how I was talking about how to quantify information, right? So you can't say gold is 1 kilo and one gram. So, right? So how do you quantify that information? And one of the interesting ways to do it is just think about how you would do it in a race course. Okay. So if you go to a racetrack, I'm not a betting person. I think I haven't been to a race course, but let's say someone comes up to you and sells a tip, right? They say, I'm going to give you a tip that, one-legged lizard is going to win the race. Okay. Right. And so one-legged horse is going to win a race. It's highly unlikely, isn't it? Right? But that tip is highly valuable, isn't it? Would you say? Yeah, because it's highly unlikely. Because if he says, this lightning blizzard is going to win the race, yeah, okay, everybody knows lightning blizzard is a fast horse, right? So you're not going to pay much for that tip. But someone sells you something against all odds, okay, like believing in yourself is the ultimate bet, right? Believing in yourself is the ultimate bet because many people have no evidence, but they have to believe it, right? So, and yeah, where I was going with that is that if you do that, if you believe in yourself and just keep doing that, saying, well, what, I'm not interested in it now, but if I just do it if I do it blindly for 10 days, right? I'm just going to, like Pascal's wager. You know, I mean, in theology and philosophy, there's something called Pascal's wager. Okay, Pascal's wager is a probabilistic argument for the existence of a supernatural entity, right? So, and you know, I don't want to go into the details of that, but one of the tangents from that argument is that, okay, well, you know, I've got this logical reason for this belief if his argument was correct, which, right, I've got this logical argument, but as a person, myself does not believe, right? Because and so you can say, well, even though everything tells me I need to believe, my brain is structured in such a way that it just looks for something that needs material evidence or something like that. Okay, you say I'm not unable to believe. Yeah, that's what I'm going for, right? So there are a bunch of people who are just unable to believe. They want to believe, right? I'm not talking about people that are unable to believe and don't want to believe, right? That's right. So Pascal's answer at that time to these people were that, okay, just be orthopraxic. Okay, so orthodoxic versus orthopraxic. And orthodoxic saying you got to change your belief, you got to believe this. But orthopraxic says, don't worry about what the right thing is, what you have to believe. But this is, you know, the thing to do. And even though you don't believe it, just do it repeatedly. And one day you will find yourself believing, right? So that is his thesis anyway, right? Whether it's true or not, we're not going to go into that. But that is the kind of belief that this calls for. Except we're not calling for belief in something that is out there. We're just calling for belief in something that's in you. And say, well, I'm just going to believe in myself. Okay. So it's a less intense form of irrationality. Okay. So if you have to subscribe to irrationality at all, just subscribe to this one. Saying, all right, so the one irrational thought that I have is that I can do it, whatever it is. Okay, and you don't have to believe anything else after that, and you'll actually get to it. Right? And I've seen a lot of people who, and the reason I say that with a lot of confidence is that I have seen a lot of people like you guys. Okay, well, not like you guys. Maybe you already feel competent. I've seen a lot of people enter CS2A. They're not confident at all, and they were not in computer science. You know, first generation even. They don't know anything about computers, and they say, "Well, you know, I'm just going to come here and find out what the big guys are doing out there." But after they get hooked, I've actually seen them go all the way and make very, very insightful comments in red that I have not seen in some of the top software engineers that I've interviewed in a previous life, right? In reputable, not well, actually reputable in places that require a lot of deep knowledge. Okay, and they've actually gone ahead. And also that's not the only thing, right? Not the level of knowledge. It is the confidence with which they help other people. Okay, and that is what I like to see as a teacher. That's what everyone else likes to see as a teacher too, right? It's not your growth in knowledge, because at the end of the day, growth in knowledge is useless, because ChatGPT will know everything more than you. Because there's information out there. It's just a matter of you install a chip maybe, right? And you go and find it. But what you do with that information, that's important. And so knowledge itself is not what most teachers look for. Is that person getting the knowledge and also getting a feel for the knowledge. Okay, I think that maybe that is the best way, until I come up with a better way to do it. Just getting a feel for the knowledge so that when someone else asks them a question, they don't have to say things like, well, you know what, yeah, okay, it'll work because Dijkstra said so. Yeah, or because it's been published in this paper, right? Look in 1959, or Euclid's proof, right? Look at this Euler proof, Euler's proof in the 2nd century or something like that, and that's why it works. Yeah, that I do, bad, stupid ass explanations as far as I'm concerned. Okay, so most of the things can be explained just in plain terms to a child, and you'll be able to do that. The people that can't do that will just rely on other external sources, right? So a lot of things can just be done hand waving. Right? If you don't go for the precision, when you go for the precision, you got to go and work out all the little details that you have to do in the quests. Okay, because if you ask me how quicksort works, I can explain it to you just using hands. Yes, but I can't explain the details to you with my hands as easily as you can actually do it. Well, you're not nowhere near that, because you got to finish blue and green, and then you get to the quicksort quest in red. But you'll find that even in blue, you'll see that in some of the quests later, quest 6, 7 onwards, you'll see a bunch of quests. There's lots of detail. Okay, you'll understand the bigger picture. And the danger there, and since everybody's here, including the online students, I think it's good to warn you right now. The danger is that there are many quests where you just read the spec and you think, I understand it, I'm going to do it. Okay, it's easy for me. Okay, and then because it looks easy when you read the spec, you say, I only need 2 days or 3 days. Okay, I'll start like 3 days before the deadline. That is the, most dangerous thing you can do. Because in computer science, as in any field really, right, getting the detail is the most important thing. Like in your music, right? So if you got all the notes in sequence, yeah, okay. And your music teacher will say, okay, that's correct. It's technically correct. Okay, now you can practice for 4 or 5 months before you now get the feel of that thing, right? But then it takes a completely different soul than it gets a soul. It didn't have a soul before because it's a sequence of notes, right? So, but it takes a long time. But a lot of people are not willing to invest that time. So you got to invest it. And all right, so data representation, right? Coming back to it, you just catch me every time I digress. Just catch me so that we don't lose valuable time. So data representation, you got to be completely facile with bits and bytes. Very easy. If you want any explanation or information. Oh, we started talking about that, right? So yeah, information, low likelihood events are more valuable than high likelihood events. Yeah, that is the basis of. I'm not going to go any more into information, but that is the basis. That is enough of a seed to plant in your heads right now, because that is enough to keep brewing. And as you learn more and more computer science, that seed will grow by itself. I don't have to do anything more, right? So the root of information essentially is yeah, I don't know. Is likelihood, okay? So if you just say, if someone tells you something that's absolutely certain, there is no information there, right? However, if someone tells you something that's unlikely, it's a lot of information there. That is the intuition we're going for. And so that's how you quantify information. The log function is used for that. And once you do that, it actually maps to a lot of things intuitively. And so from there, we just take it, and there's a lot of things that you can do in information theory that actually has a lot of bearing in machine learning and data engineering, machine learning, and artificial intelligence. Because a lot of ML is based, it's just statistics in disguise. Even if you're dealing with deep neural nets, just blindly feeding data into a deep net is not going to get you anywhere. Yes, you got to select the data first. That is what requires great insight and knowledge. And because, speaking from my early days as a research engineer, right, 90% of the work isn't just cleaning the data, in fact, not even using the model. So cleaning the data and normalizing it and making it in a shape and, right kind of precision and everything so that it's easy and it's right, correct to map, and reduce the noise. That is where a lot of your intuition comes in. And how do you reduce noise in data? Right? Then I'm talking about a lot of topics in machine learning and data engineering, we're doing kind of in graduate studies, but it's all the same, right? So that's why I'm taking the liberty of talking about it now in the first lecture. So how do you reduce noise? How do you reduce noise? Because when you reduce noise in data, you get better models. Yes? You have a lot of noise, you're not going to you'll get a model that's very white. Yeah? So you reduce noise, exactly the same as, practice like in a musical instrument, right? So initially you may get the tone rough, about approximately right, but you keep on doing it again and again, then your tones will get narrower and narrower. You get more accurate. You get hitting, on the dot, bam, bam, like that. So you get more accurate. And the reason you can do that is because repeated practice exposes you to all the different ways you can go wrong. Okay, that is what separates an expert from a novice. Okay, an expert has internalized in his mind all the ways that they can fail. So they can actually fail in their heads before they actually do with their hands. And failing with electrons is a whole lot better than failing with whole atoms. Yes? Because you'll you simulate that in an alternate universe, and they'll know that's not going to work. And if you see the chess masters, for example, in action, it actually feels exactly like that's what they're doing, right? Because they're not actually going through the details of every move that a novice painstakingly goes through. Right? So, if I move my pawn here, that knight will take a 3-step move, and so on. So, they go into all the detail, right? But, chess masters, they just seem to know. They look at it and say, all of that is not going to work. This is going to work, okay? They do that, and they're not even consciously thinking through all the moves. But they are actually consciously, they got a picture of all of the things that they could go do and they could go wrong. That's because of lots and lots of practice, okay? Whether they played real games or they played games in their head. Okay, this is in their bed and they're looking at the configuration and say, all right, okay, right? You can do that, right? With lots and lots of practice and imagining things repeatedly, you can, and they've done this and they've seen, okay, if I do that, that's going to go wrong. So if I've got to watch out for the pattern, and you remember all these patterns. Okay, so, and so repeated exposure will expose you to noise, okay, which was indistinguishable from real data before, right? So the SNR ratio, this is the DSP people call it the SNR ratio, signal to noise ratio, SNR, right? So the SNR is high. There's a strong signal. You can recognize it easily, right? And you can buy a cheap model and that will actually latch on to the pivot or whatever it is, right? But if there's a lot of noise, then you can't get, the models are expensive. People have to pay, millions of dollars sometimes to invite, machine learning engineers to look at the data and, recommend something that works for them. And the reason they are so expensive is because They've had a lot of experience, and they can look at the data and say, well, 90% of this data is noise, but I know exactly where the noise is. You can cut it all out using these filters, right? And identifying that, so that once you get the real data, you can actually, the thing is, what I've seen is that once you've filtered the data, once you've got the noise rid of the data from the data itself automatically is most of the time screaming the hypothesis to you, right? Most of the time, people say the hypothesis is based on the data. But what I've seen in my scientific career is that many times when the data is prepared for the hypothesis, the data is already screaming the hypothesis out at you because the data has been filtered in such a way that it is conforming, which is basically reducing noise. Where you have to be careful when you're training AI and all. I've never trained an AI system, not the modern ones anyway, is just to reduce bias, is to make sure that, well, that's not good. All that. Okay. So yeah. So you want let's go back to the data representation. You need to be conversant with bits and bytes, converting from one base to another. That's a great game. Okay. Some of you, Rebecca, for example. Oh, Rebecca. Yeah. I started on. Let me go around here. Rebecca, Juliana. I forgot your name. Sorry.
Kira.
Kira Finlay. Yeah. Okay. And Muhammad. Yeah. So I just call it random names from time to time. Okay, just to make sure that I remember. Okay, Eric, and then Sweden. Okay. So, Isidore. Okay, Isidore is a very unusual name. So, but that's the reason I should remember it. Okay. So anyway, so data representation. Yeah, bits and bytes. Hexadecimal, super duper easy. Okay, you want to work at problems, you can just use whiteboard. A bunch of people can get here, use whiteboard. I think it's visible on that camera, or Eric can turn it on my own. Yeah, you can get that. And then we have one more lecture to do data representation, but I'm thinking, right? And tell me if I'm wrong. You can also tell on Reddit. Okay, so get on Reddit and say, well, let's do data for one more week. Yeah, okay. But I'm thinking we don't have to. What we'll do is just say, you already know data. You're going to do data today, maybe tomorrow, but from Thursday onwards, let's just start coding. Is that okay with you guys? Yeah, let's just coding simple programs. In fact, even today, one of you, right? One of you, maybe Chris, or anyone else who has already done quest number one. Who's already done quest number one? I think a bunch of you have done. Yeah, okay. Yeah, I'm pretty sure. Yeah. So one of you, maybe not Chris, okay? Someone else who's done quest number one can basically take. Just I'm sorry. User, right? Yeah. How do you connect that thing into your Mac to the? Oh yeah, it's got a USB-C. Okay, so we got to figure out a way in which you can connect your Mac to the. But anyway, you're doing it on Zoom, right? The thing is, I used to have this adapter, but I just left my Mac and everything at home. I'll talk to Mario and figure out how to do this. But one of you can hopefully get on Zoom and say, share your screen so that everybody else can look at your screen. And then you can go to your text editor, note, and that's Mac, right? So you can go to text edit. Not now, right? Yeah, maybe Rebecca, you can do it. Yeah. Okay. So not now, when you're ready. So she would go to a text edit window, create this hello world, and save it. .cpp and drag and drop. That's all, right? Simple. And get the rewards. And that's it. That's a live demo, and it'll be recorded. Yeah, it'll be recorded, and everybody will see it. A lot of people are asking. I think Namrata was planning to make a video of this at some point. Yeah, but then she won't have it. She's the other organizer, but she's not here in class. She's actually a student at UCSC. So there's actually a bunch of students here. I think from UCSC and UCSB, right? So maybe online guys. Hey, online guys, you haven't spoken at all. If you got the audio on for your
Yeah, should be on. I think my computer's about to die though, so
Oh, is it? So you can plug it in,
I left my charger at home.
You whether you can plug it in.
I did.
Yeah, I left my charger at home
But
though.
you don't have a plug point there at all? You don't have a power source?
Yeah.
I could turn my audio on.
Yeah, you can turn your audio. Oh, but you Oh, because of the feedback. Do you have an adapter at all, Eric? You have an adapter? You don't have, so you can't plug it in, even if you, yeah.
Nah, I left it at home. Sorry.
Okay. Maybe someone else. Yeah. And your brightness too. Maybe since you're plugged in now, you can max out on brightness. That's all we can do? Wow. Okay, so it's so different from a Mac. Yeah, I'm pretty sure if Rebecca maxes out the brightness, it will be blind. Oh, this is an old Mac, right? Is that the Max?
This is just a MacBook Pro.
No, is it a max brightness?
Oh. This is, yeah.
I don't know. Maybe the new displays are different because I got this MacBook Air just 3 weeks ago. And you know,
The new one there's.
it's insane because you know if I get it on max brightness, I just have to squint.
Yeah, I know. These phones. I think the newer Macs are like 4 to 5 times better than the screen.
Oh, is it?
Yeah,
You mean yours or Rebecca's?
no mine.
Yeah. Well, I can see that. Yeah. Anyway, all right. So that's it. Okay. So if you have and floating point notation, it's very simple. All of these concepts are like super duper simple. Okay. Super duper simple. It all looks like, you know, the name floating point, you know, it's very intimidating if you haven't come across it before. But all of these are very simple. This is names stuck on just very simple concepts we know. And once something gets behind the name, it can now say, because, you know, that's the same as in real life. All right. If you're your true self, if you put on a face, you can be whatever you can put on any face you want, right? But you only got one real face like that. So once you got a name, people will say won't be able to see what it's about, and they may think, oh my gosh, that is really hard. And no, it's not hard. Okay. Actually, in fact, there's something called the duck feet syndrome. Okay. And since you're all CS2A students, I think this is very good to say, right? To share with you right now. It's called duck feet syndrome. I don't know if you, how many of you heard of the duck feet syndrome? Nobody? I'm so surprised. Okay, Eric knows a little bit. Okay, so I learned of this when my kids went to Pali, okay, Pali, and I think I was, you know, at one of the social events, and a parent was talking, and he explained it to me. It is that there is this feeling that everybody else does not have to work as hard as you do.
Okay.
Yeah, okay. Oh, then you can turn on your, oh, that's great. Yeah, how come we got you know, Rebecca's camera on your screen?
It's a very good question. I think our mics. Is your mic
Oh,
on?
it's active.
My mic
Yeah,
is,
yeah.
oh, is
Yeah.
yours on too?
Zoom is like,
No.
I'm not 100% convinced that Zoom has got correct speaker ID. No, active speaker ID. Because many times, even in Zoom classes, it just switches arbitrarily, right? So some student is asking a question, and it will show some other student.
I
And
think it shows the active speaker.
no, I'm saying it doesn't always do that. It's not accurate. It's not accurate. But it is. I think it's possible to be more accurate, but I don't know why. Anyway, this is right now. You can. It's actually possible to do a lot of these things technologically, and I think I think it is safe to say now that if you're not getting the best performance from anything, if you know if a software like Zoom or whatever it is, they give you crappy stuff. It's just that they're probably just economizing and using less power than they can because the technology is there to give you the best for many of these things. So you can say I'm going to use a a language model with range on only 2 billion tokens. Yeah, but you'll still have most of the things that you can generate, but you'll see the shortcomings. So it just becomes a matter of resources at some point. It's essentially what happens everywhere, everything, right? So with AWS cloud, everything, once you resourceify, because at one point I remember in 2007, I wanted to make a service, a web service. And I had to buy it. I went to Fry's, I bought the motherboard, I built the computer, had it running in our basement with wires, and I had to dust bunnies, you got to vacuum them. It's a pain to clean them. And it's a server running on a Comcast business line. It was real pain to maintain. And then all of a sudden Amazon came out because they said, this is, what you're doing is everybody does the exact same thing. Why should they all suffer? And I think Google, Microsoft, everybody, right? Once you figure out that it can be made into a resource that can be commoditized, they can go into fine-grained details. And so Amazon started selling CPU cycles by the cycle, right? It's incredible, isn't it? So you don't have to, in fact, you can write a Lambda that takes the exact number of machine cycles you want. Okay, you can pay for that much. So you don't have to buy a whole big computer. And so everything like that becomes possible with these cloud services. Yeah, and Panini was in that class that when we talked. It's actually cool, right? If you continue all the way with Red, and especially if you become an internet nonlinear media and all in the end, you'll have a lot of opportunity to dip into cloud, and we'll train you also, right, into the essentials of cloud. It's my personal opinion, having also taught the cloud course, is that with many of these cloud courses, certificates out there, they're too pedantic in the sense that there are certain essential skills you need to know, which will actually get you up and going in cloud easily, very quickly. And there's a lot of other things you can add, authentication, a whole lot of things, but you need to get this going first. And then you can say, okay, now I want to add cognitive, or that, and so on and so forth. And then it's easier to learn these things. But if I look at the syllabus that I was supposed to teach, it was, just going through one after another without any real application. But, I got those were also recorded and they're on YouTube. You can go right to the very end. You'll see. And in fact, Panani may be in those videos too. But we ran it differently, right? And we said, we're not going to go through that. We're just going to go with projects. Okay. We'll just say big, interesting things. This is what you can do in the cloud, right? Go ahead, do it, create a web server, right? And hack this and, and so on and so forth. And by doing these things, you get to fail. And that is the most important thing. Okay. You've got to fail. Lots of people shy away from failing, and they shy away from failing because they don't believe in themselves. Okay. That is the reason. You got to have that irrational belief. If you believe in yourself, you say, it's a failure. I will come back tomorrow. Maybe I'll get it. Okay. So you got to believe that. I don't know how you get that, but it's just repeated practice. I think you keep on going at it. You find different ways of failing, and it's hard to find different ways of failing. Okay. Most people will find 4 or 5 ways and they're happy with it. Okay. But what happens? You go, work for a big company and it fails in a completely different way. Yeah, no, you got to be like that plant that, hits that branch from many different directions so that you have this internal model. So you got every problem in CS2A, all these quests, you pass it. You do something and you pass it. Okay. Yeah. Okay. But, I've put in many quests so that, it's not that easy. But even if you pass it, well, maybe not with these quests. You got to do a really good job and you get a good picture. But I know the previous assignments that I used to give out before I built the question system, people can pass it. People can pass it, but they won't have a chance to explore the area, which is really what is important. Okay. You need to be able to explore. And in order to explore, you need to fail and not be afraid of failure. Because if you're afraid of failure, you're going to ask someone else what the answer is. No. You got to go to bed thinking, okay, well, I failed. Maybe I'm not good. No, you should say, I'm going to try again tomorrow. Okay. That's what everybody posts, right? Chris also posted that saying, if you can't, if something just doesn't work, just go to bed, right? You'll come back the next day and you'll find that everything is different. So yeah, that is really cool. Do you have any questions for me? Otherwise, you should just basically get up, stand up and just mingle, right? And get into groups 4 or 5. And then if you have a question about, and you can go from group to group and say, are you guys talking about Tue's complement? Because that's the one that I want to talk about, right? And you may find a group that's talking about Tue's complement and you can work with it. But before we do that, let's do Rebecca's demo. Did you say Becky or Rebecca, by the way?
Rebecca.
Rebecca, yeah, okay. So yeah, let's do Rebecca's demo first, okay? And after that, we'll just say everybody stand up and then find groups that you can. Okay, cool, great. So why don't we start? Okay, so Rebecca here is going to demo. Hey, Pani, by the way, did you have something to say? I never gave you a chance. Oh, Chris, by the way. No, I think you good? Yeah, you good? You good? All right, great. Yeah, so Rebecca is going to demo how to do the very first online students there. Can they hear us?
Yeah.
Okay. All right. So yeah, so she's going to demo this very first quest, and it's exactly the same process all the way. And she's going to create a file and then drag and drop. And so just watch this. And this is, I think we'll make a YouTube clip. Okay. I think it's got a clip feature. We'll do a YouTube clip and post it on our channel. Oh, ready also. Yeah, this is Jeff has written another note here. It's exactly the same message. But he's really, really worried that we must start mooching on this stuff. All right. But I told him, all of my students are like super duper well behaved. They're you're like, as quiet as a mouse here. And because when I was a kid, in my classes, the teacher had to shout all the time to just keep us down, to keep us the volume down. Well, shut up, guys. It's too much noise in the class, and we always be talking to each other. But here it's not like that. Listen, the classes that I've taught, you guys are here, and you're all, here more interested in the topic and what you can learn, which is an absolute delight and a boon for teachers. Okay, so I absolutely love this. Is that during your time in college or? All the way, I think. No, actually, no. College. Yeah. No, in high school, I used to talk a lot. In college, we used to talk a lot until the professor came into class, but then after that we stopped. Yeah, that's good. But after that, for masters and all, it doesn't really matter. They want you to talk a lot. Yeah, Rebecca, sorry, you can go ahead, okay? You can also talk through it, okay? You can talk through it if you want. You say, I've got this file, I'm creating something in text editors.
Okay.
It's all yours now. I'm not going to speak.
Okay, not sure if I should show the code I have, but this mostly
No,
from,
it's okay. For the first one, it's okay.
okay,
Yeah, you can actually go to, you can open an empty editor and type it in from scratch too, so that everybody will know.
okay. So I use Visual Studio Code. So for me to create a new file, I just go up here. Hopefully everyone can see this and hear me, but I just name it hello world.cpp, C++, and it says it already exists, which it does. So maybe make a new one. And then what I just do is I use the Wikipedia, and I just kind of this is really all that you're writing. So not sure what else to say, but if anyone has questions, let me know. And then to run it in the terminal, I just do on my computer, I have a Mac, Control Option N, and it should, yeah, hello world. So that's how I did that.
Awesome. Is that it? That's it, right? Because, yeah, nobody has any questions? Yeah, okay, cool. All right, that was the first class, and it's exactly the same for every single class. Every single class, okay? So, and, you know, obviously the first one is just a hello world. The other thing is you're going to do exactly the same thing. Well, I think 3 and 4 onwards, you may have multiple files. So you just have to grab all of them and drop them. You'll start getting, the first 5 are easy, I think. Would you say that, Christopher? The first 5 are easy. And I think it'll slowly start ramping up. But I think in 2B, it'll ramp up much faster. But it'll be worth it, okay? 2B. So you shouldn't be scared. Because I know there are sections that you can enroll in 2B. 2B sections you can enroll in here. That you don't have to know all the, you know, everything. You can just say, well, you know, this program works. I was teaching one of those before I had the questioning system, because I couldn't check for every corner case. You know, if a program works and I get a rough idea of, you know, all right, the students are, so this is how it works. Yeah, okay, they get 20 out of 20 for the assignment. But, you know, I found over a long period, by a long period, I think maybe it's 5 or 6 quarters, no, for 3 or 4 quarters before 2019. Yeah, it didn't really help students at all, because they would make the same kind of errors repeatedly. But with questioning, it doesn't happen. You'll find it yourself, right? So you'll make some kind of error and you won't get any trophies. And then you'll ask in the forums and someone will tell you, well, you know, that's why you're, you know, crapping out there. And then you just know, right? You won't have, because you've been bitten once. You didn't, because hearsay, you'll forget. And so, yeah, you'll find that that is, yeah, that starts happening from 2B onwards. Yeah, before, yeah, it was very loose. People can just pass. Yeah, I wasn't able to tell if students actually understood it. You know, yeah, that I think I made this point in one of my online classes. The need of understanding, or people saying I understand things. You can understand things at various levels. You say, how does the radio work? You can, you know, give a hand wavy high level explanation, right? Everybody can do that. Kids can do that too, right? So there's a waves down here and like that. But you know, engineers get right down to the detail, and they know exactly why things go on, right? So and so on, like aircraft maintenance. There's so many details, yes, and people can look at it from a distance and say, yeah, okay, well, you know, all right. But if you've been there long enough, right, that's got to be long enough. It's just got to be long enough so that you get different perspectives. You fail in different ways. With a good boss, okay? Fail in different ways, meaning you should have a boss. If you get a boss that is not tolerant to failure, you should just say, no, I'm going somewhere else. Okay, eventually when you start working. Because you need to fail, especially when you're young like you guys, okay? You need to fail lots of times. And you should have a boss that just tolerates that, saying, okay, well, it's good that you failed. Now go back and fail another time. It actually happens here. When I was learning ceramics in our ceramics lab, which is over there, Vanni also was a student in the ceramics lab. Andy Rubel, he used to teach that. He still teaches that, I think. It's actually cool, right? If you're, so that's, those are courses you should enroll in, okay? If you're looking for other courses to fill up your unit count, yeah, I've got to have like a certain number of units, yeah? Don't go and enroll in these hard ass courses, like, you know, in STEM, you know, I'm going to do, you know, third order differential equations, bam, like that, right? And then CS2B or something like this. No, make up your mind and say, I'm going to be a kick-ass computer scientist, okay? So I'm going to put my entire thing here, but I got these other units, so I'm going to do some fun stuff. You know, I'm going to go to the theater department and do a, you know, an improv class, which is really fun. Okay, I've done that. Okay, and then Andy Rubel's ceramics class. And I got started talking about that was because in ceramics lab, one of the exercises you got to throw a bowl, and I failed miserably, right? And it was just not working for me. I tried so hard, and I thought maybe okay, well, you just need the sense for it, and I don't have it. You see, that's a fixed mindset for me at that time, and I thought I couldn't do it. So I asked Andy, right, how do you do this? To tell me the trick. And he said the trick for getting that right is to just sit down and throw 10,000 more like that. Okay, and that was right. That was the right advice, the best advice I got, I think, because by each time I threw it, I could feel something else that was wrong, right? And then over time, your mind just builds up this model of all these things that could go wrong, and automatically your fingers adjust to against them. And so you don't even know, right? Like you reach for a wrench that right? That is the right thing, or whatever it is, right? Or design this part and say, well, that's too wide, or and all those things are like this becomes second nature. Thank you so much. Hey, yeah, and again, hang on, Roger. Okay.
For those, that's great advice. They're kind of well-rounded. But when it comes to applying to a CS, like one of those universities, top universities, for going for a job interview. Since you were an interviewer, would you look at both applications, one with like high level courses and high grades?
I don't look at grades at all,
You don't
actually.
look at that at all. So when it comes to the interview process, and other companies, Google or Facebook or Meta, they don't really judge based on that.
Your expertise, your natural expertise, because you get to converse with them, which you will be doing, by the way, in this class. There will be problems that you'll be solving, very much similar to, except we won't be using a whiteboard like in a professional interview, but you're going to be doing it on Canvas and something like that. If I can set up things like that.
So it would be acceptable to take those easier courses or different courses that straight from your computer science path.
I'm saying they should be easy ones. They should all be easy and relaxing ones, so that because when you're doing something like ceramics or something like that, you're not thinking about hard problems to solve. This takes a different kind of mental juice, yes, because this takes something that you can. It's I think to me it feels diametrically opposite, right? That one feels more relaxed and you can just be yourself, whatever the hell. Here you can be yourself too, but it's in a different sense because you just have to withdraw completely to focus on this. Yeah, so it's two different skills. And if you take 5 courses that are like this, I think it'll be hard. And many students don't know how to pick the courses. And that's why it's important, I think, that maybe the counselors give a good, breakdown of these things. But I see a lot of students, for me in my 2C, there's a lot of students who are enrolled in all the hard courses in STEM, all the hard courses, okay? And then they're doing it in 1 quarter. It's a total waste. It's not only not, it is not going to, I don't think there's enough time for all the information to sink in and do a good job, really. But it is not worth the struggle that I see from students. I think that's what I was going for, right? So why do people have to kill themselves? It's not like right now. If you were back in the bad old days when you could get killed by a lion or something like that. Yeah, I understand that, right? But today genetic engineering, you guys are probably going to live for a couple 100 years at least. Yeah. And if you get your life done in the first 10 years, or 20 years, whatever the age is, right? So what are you going to do for the remaining 180 years? So you got to pace things so that there are things that you can take it easy. And it's the same, I think. It's generally boils down to life advice. And we got very few people here are very young. Okay, so I'm going to take the liberty. Well, I forgot what I was about to say. Okay, so let's forget that. Okay, so anyway, so why don't we just now all get up and get into our groups and start talking about these different concepts. Okay, find groups that talk about the specific thing that you're having trouble with. Okay, you can also invite me or Chris or to join a group and also when you're doing the chat amongst yourself, if it's a group of 5 people or 6 people like that. At least one of you should have a camera like Rebecca or Hussein does. Right, Raj, your camera's on too?
Yeah, it's on.
Yeah, okay. So so have so that the online students also have this sense of participation. How does it work now? Because I'm thinking about the cloud recording. How does the cloud recording work? Because if different audio feeds come in at the same time, it's not breakout rooms or anything. Gee, maybe I have not thought this through completely, but all the same, that's fine. We'll just have a group. I think the audio is just going to be this group. I think it's just that's what it is. Okay, so if you notice an interesting conversation in your Zoom in another group, then you can just pause and listen to it. We'll see if we'll play by ear. How about that? Okay, we'll discover a good way to match this. If it was all on Zoom like we do in our online classes, I think it'll be much easier. But this is a new format and I'm experimenting, so we'll see how it goes.
You fail, we'll find that out.
Yes, exactly. All right, so how about this? All right, so why don't you all get into groups and start talking about one of these concepts, and you can call one of us to or me if you're stuck with something. Okay. I'll think about it very well. So what we're going to do is take Isidore's question and work it out on there.
Okay.
Is that good? Is that good with you guys? Okay, and I don't have to do it. If someone else wants to do it, that's fine too, but I'll describe the problem. If one of you wants to take a crack at it, go for it. Otherwise, I will do it. How about that? Yeah? Okay, right, so what is the problem?
Representing negative numbers, which is binary.
Okay, all right, okay.
Can I sort of?
Yeah, totally go for it, okay? Yeah, just make sure that the thing is. Oh, it's a max.
Can I see that?
Yes.
Yeah, I think this is fine.
Okay, so I'm just.
Yeah, I think that's better.
Yeah.
How old are you guys? You guys 18? Yes.
Wow.
Oh, wow. That's been hard to do this for me.
So if we have this sequence of bits like it is.
Yes.
Binary, so we have 4 bits, right? And then we add 1.
Uh-huh.
So what we would end up with is this, right?
Yes, yes.
So, but we still only have 4 bits to work with, right? So
Yes.
how does the computer know that we should sort of say into account that this one?
Okay, fantastic, fantastic.
I don't really understand.
Thank you,
practically
Rebecca.
how
Right,
it
this
works.
is a great question, okay? It's basically the root of Tue's complement. It is what is it or just described? It's the motivation for something, this very cool thing, cool technique called Tue's complement notation. Do you want me to talk about this?
Yeah,
Because
sure,
it basically
sure.
directly leads into Tue's complement, yeah?
Yeah, because
Okay.
I sort of get it, but then I don't get like.
Yeah, cool, cool. All right, I like this. I like this. All right, thank you. That's great. Okay, so Isidore's question is, right? How does the computer know that this is actually -1? Because if you add 1 to it, you get 0. Yeah, and this is because if think about if it's just binary numbers. Okay, we're not talking about digits and bits yet. It's just binary. In binary, you don't have a problem with negative numbers because if I want to have a -2 in binary, right? I just say -1 0. Yeah, that's 2 in binary. 1 0 is 2 in binary. Yes. Yeah, so -1 0 is negative. But however, I can represent that. I can represent that on a digital device because there's no symbol for a dash. Because I can say that a 0 is absence of current, right? When you have current flowing through a wire, right? And there's no current, it's a 0. When there is current, when you get a shock, right? And that is a 1. So I have a means of storing information because when you have distinction, I can make information. When you have no distinction, there's no information. So now, given that I have zeros and ones only, and I don't have a middle state, like I don't have a switch that can have 3 states, right? Only 2 states. That's why it's a binary item, 2 item, bit, bit, right? Only 2 states. Now that is a challenge. How can we do negative numbers now? We don't have a negative dash sign. Now, by the way, it's exactly the same problem as representing decimal, fractional numbers, right? It's just an extension. Because you don't have a dot, you don't have a dot symbol. Oh, this is my screen, right? All right, let me increase this is the maximum brightness. Oh, okay. All right. Oh, I see. Maybe this light is oh wow. No, that's okay. Yeah, as long as they can hear me, that's fine. It's going to be recorded in the cloud. Yeah, okay. So how do you represent a negative number? This is a challenge. It is exactly, and once you solve this challenge, that is why I think this is the first. Well, I don't know the sequence in which I put them in module 0. I think the sign magnitude, the sign challenge is the first challenge that you should solve. Once you solve the sign challenge, you automatically know in your head how you're going to solve the point challenge. Oh, I don't know how to do a dot, right? 3.75. There's no dot symbol there. No half current, right? Not full current, half current, 0 current. No, you don't have that. So how do I do a dot? But because you've solved the sign problem before, even without me telling you, even without you reading the modules, if you just had 2 hours, right? Max 2 hours, I think, right? I've done the the sign problem. I know how to solve that. Now I have the other thing, which kind of similar, but I don't know how to do it. I bet you'll find it yourself in 2 hours. Maybe not the exact thing, because obviously you can kind of solve it in different ways, but you'll have the exact technique, right? It's a similar technique. And it's very ingenious. Okay, what it does is actually takes a shortcoming. It's incredible, isn't it? I think this is one of the beautiful things in computer science, where we take what is a disadvantage, a shortcoming, and turn it into an advantage, a blessing for us. Okay, so what I mean by a disadvantage is that a computing device is necessarily finite computing media. That's some beep from somewhere. Okay, so it's a finite computing media, meaning that you can only store a finite number of bits anywhere, right? You can't say infinite information, because you actually have a quest in CS2B where you have to figure out a way to store infinite information. Okay, interesting thing on its own, but technically you don't have to store infinite information, finite information, right? So it's a limitation. Anything that's finite is a limit, isn't it? It's a limit. That's the definition of finite. It's got limit on limit. Okay, so it's limited. We don't want to be limited. Okay, however, because we have this disadvantage, you can start thinking, is there any way I can turn that disadvantage around? I actually had a much better phrasing of this, in a long time when I taught this in person, to turn the disadvantage into something that's beneficial for you. Okay, and so what we do is go right back to, there's this challenge where I have to represent negative numbers, but let's not focus too much on like solving a problem, focusing too much on superficial details. You'll get lost in a morass of things, right? And say, what I'm interested in is, what happens when you subtract one number from another, okay? I don't actually care what the representations are. as long as it satisfies everything that subtraction should do, which means that if I take a number and add the same number to the negative of the same number, I get 0. That means that this number is a negative of that. Would that be okay? So it's just a practical thing. So it's not a real negative number. We just make a practical adjustment to a limitation we had that now gives us a power all of a sudden to be able to store negative numbers. How? Right? Now let's take the social security numbers, right? And let's say, let's go to a planet where you only have 5 boxes for social securities, right? So 4 boxes. Okay, 4 boxes. Only 10,000. Only that's not the right way to divide up 4, right? So the right way, I think the better way is to divide it 2 and then 2 more. That's more even. Okay, all right. So yeah, that's all. Right? That's all the space I have. Those are all the transistors or the bits that I have, and that's all. That's a limitation for me. So I want to be able to represent numbers from in 4 bits. How many different numbers? Forget about the sign. Okay, how many different bit patterns? Essentially, different bit patterns are different. Yeah, Stanley.
Choose about 4, which is 16.
16. Yes.
Yeah, 0 to 15.
Yes, 0 to 15. Right, and there are hexadecimal digits. Thank you, Stanley. Right. So you basically have these 4 digits. That means you only have 16 patterns. So you can go from 0 to 16. However,
15.
thank you, Stanley. Yes, 15. Yeah, 0 to 15. Now, I'm going to say, what I want is why I don't want all positive numbers. I'm willing to sacrifice the range. Basically, I have this range of 15, 16 numbers. I'm going to take that range. I'm not losing anything or gaining anything. I'm going to shift the range, right? Instead of 0 to 15, I'm going to go from -7 to +6, -8 to +7. Okay, -8 to +7. So which means that previously what we had was 0, 0, 0, 0. That was 0, and then 1, 1, 1, 1 was a 5. Yeah, 1, 1, 1 was a 15. Right, that was a 15. Now we want to say that, can we get a system like that? Now let's go back all the way to what subtraction is. We just want a way in which we have 4 boxes and numbers in those 4 boxes. Okay, numbers. We'll go to decimal. Okay, decimal is easiest. Anytime you have a problem in binary that you cannot understand, just think about what you would do in decimal, because it's exactly the same. It's a calculus. The calculus does not mean dy by dx all the time, right? Calculus just means blindly moving symbols along. This is the calculi or pebbles on, I think in Latin, calculi are pebbles. So in the ancient days, I guess, in mathematics, you didn't have these sophisticated computers. They would move using calculus, like abacus in China. You move pebbles around. So I think this calculus is just getting an answer mechanically without conscious human thought. That is calculus. So you have many different calculi. You have, mathematical calculus, derivative calculus, propositional calculus. So many different calculus. We're only, usually familiar with derivative calculus, I think, mostly. Right. Anyway, so I don't know how we got started talking about, right. So we have these 4 digits, and let's say if we have these decimals. So let's say I have a number 3,245, right? And I want the number -3,245. Right, negative 3,245, right? How do I get that in here in the social security box that does not let me put a negative sign in there, right? Only numbers. How can I do that? So I do that by saying I'm going to take advantage of the fact that if I add another number to 3,245, some X, Y, A, B, C, D, right? A, B is 4 digits, A, B, C, D, right? I add those 2 together, I get 0, 0, 0, 0 under the places that are important to me, right? There's going to be an overflow, like Isidore pointed out, and it's going to be gone because I have no place to store the overflow. It's an 8-bit computer, right? So when you store 2's complement, you tell the computer saying, I want an 8-bit or 1 byte 2's complement number or 2 byte 2's complement number. So it knows, the system knows already how many bits are there. Because you cannot have a negative number until it's on size, right? So the size is like super duper important, because once you know the size, it can do this thing to calculate the negative by doing this clever thing. So 3245, how can I get 3245, right? How can I get these digits so that I add them and I get all zeros, right? And we can do that in 2 steps. And the first step is go get all 9s first, okay? It's easy, isn't it? Get all 9s, because it's just a 9's complement in this case. So it'll be 3, 2, 4, 5, and then this will be 6, 7, 5, 4. Yeah. Now all you have to do is add 1 to the 9's complement, and that will give you, if you add 1 to this 9's complement, that will give you a sum that will be 10,000. Yes? Now you can discard that one bit, that the leading one, because you don't have space to store it. And that was our shortcoming, but we turned it into our great advantage now, because now we have a really good way of representing negative numbers, because the practicality of the result, this is really just practical, right? It's not a real negative number. It just behaves like a negative number in all possible ways that we can think of. Yes, that's really super duper important, because the concept of negative numbers, the concept of two's complement really only applies to finite devices, because it doesn't apply to real binary numbers or real numbers or real quantities, because they can have negative signs. It's just a concept. But if you get to a finite device and need to represent it, you need to put a mark there. But if it's a finite device that has many states, you can do things like, crazy things like dash and things like that. But if it's just a finite device that only has two states, you got to come up with clever ways, and this is one of it, right? So if you have a base 2 number, you do exactly the same thing, okay? And let's go to, where is Eric's number? No, Isidore's number. I rubbed it off or something. Yeah. Sorry about that. Okay, so if you have a 4-bit number, okay, so 8-bit is usually what you get in 1 byte. But let's say let's take this fictitious land where they have 4-bit computers, okay, not 8-bit computers, 4 bits, and let's say they had a 0, 1, 1, 0. What is this, by the way? Right, 0, 1, 1, 0 in 4 bits. What is that in binary? Can someone tell me what that is in binary? 6, yeah? All right, thank you. I actually wasn't thinking about it, right? Someone is going to tell me, I don't have to, right? So, all right, so I want to get -6 from here, okay? This is 6 in binary. Yeah, this is 6 in binary. I want to get -6. And here's where we're going to run into the thing that Isidore pointed out, is we're going to manufacture a number. A manufactured number that when you add to the first one, you get all zeros in the significant bits that are important to us. And you get a 1 in a place that we don't care about, and we can toss. Yes, that's what we're going for. And how do we do that? Yes, Roger.
Yeah, when you added 6,704, did that convert it to from positive 3,245 to negative 3,000?
Yes. Okay. All right. So therefore, you added 1 to this, and you got 6755. Yes. 6755, we assume for all practical purposes is -3245. Isn't that cool? Okay, so the representation is actually of a positive number, but we just assume it's a negative number, because when you add it to the other one, you get all zeros, 1 with the 1 tossed out. And the tossing out of the 1 is what gives us 2's complement. Isn't it cool, isn't it? Yeah, so it's very similar. Okay, when you come to floating point, you just have to come up with another technique. It'll be different from the one in the book. It'll be different from one of the modules. Okay, it's very similar. All you have to do is, all right, now I have a way to represent negative numbers, right? Let's just say 2's complement, because sign magnitude is super simple. Sign magnitude is saying, I'm just going to use 1 bit for the night, right? So I'm not going to talk about sign magnitude. You can find out yourself. But 2's complement, lots of students get stuck. So we had a chance to talk about that. But when it comes to floating point, now you know how it's done. And so you know what the challenge is. I got a fractional number. How do we do it? Now, then you start thinking, all right, how would I do it as an engineer? And I have to do this. I'll just break it down. A fraction has an integer part and a fractional part. Let me see if I can do separately. Okay. So then you'll say, right, no, I got 8 bits. So let me say I'll store the fractional part in 3 bits and the integer part in the remaining. So that's your first step. Yes. Now you send that packet to someone else, they'll look at it and say, all right, now, break it apart, and I got the integer, I got the fraction, I got the whole number. Yeah, so that's the first step. And the rest of it is just, very similar manipulation. You say, well, instead of storing these separately, we'll actually store it as a power of 2, right? Times for example, if I wanted to say pi, 3.141, right? That's pi. But if I write it in scientific notation, I don't need the point. I can say 3141 times 10 to the -3. Yeah, is that correct? Yeah, 10 to the -3. That's also pi, isn't it? So if someone asked me, what is the value of pi without using a point? I'd say, all right, I'm going to give you 2 numbers that are both integers, and that give you the value of pi. The first number is 3141, and the second one is -3. And you can use that to find out what the value of pi is. Yes, that'll work too. And now I don't have to send a point for which I don't have a symbol. Right? So that's really cool. And now, so that's the problem, and you've solved it now. And now all you need is 2 numbers. So you represent this number and you represent this number in different numbers of bits, put them together in a package, which is 1 byte, and that is your floating point number. Actually, all of these, right? Many of these things, simple concepts, okay? Super duper simple concepts, just hiding behind names that students somehow seem to think are complex. I don't know why. But there are really many things are really super duper simple. Okay, so don't be fooled. Don't be fooled by the chapter title in the text or the modules, because sometimes when you look at the chapter titles, oh, how to display n-dimensional trees or something like that. And but if you look at it and you just look at each section and how they break it down, it's all very simple. What you've done before, they just taken it and applied it in different places. But a lot of people, yeah, it is. They think that, oh, all right, I can't understand it. They've made up their mind already. That's the thing, right? Whether they try things or not. And that's open-minded. And if you're close-minded, you're not going to give yourself a chance to say, well, there's something in there that I could possibly benefit from. You'll probably just say, you'll have a close mind and say, oh, that's not for me. I'm going to go somewhere else. Because, the world is full of lots of tempting and tantalizing things. So you just go. And at the first sign of temptation, and so when you say, no, I'm going to figure out what the hell is going on here, that makes all the difference. And I say it makes all the difference because that is what is required to find that nature at its core is actually very simple. It's only people that make a big thing out of it many times by coding it with jargon and many times. I actually even in reality, I think, right? So lots of things that need to be, well, obviously, some things you need a lot of preparation and understanding to get to the bottom of, to the detail. But in terms of what students are given, I think that many of the topics sound far more complex than they really are. Lots of students shy away from some of the quests. Or some of the problems, the quests that with the quests so much better now, because you cannot do a subsequent quest until you finish the previous one. You got to do everything in sequence. But before, when I used to offer the regular assignments, there was no such constraint. And as some of the students, many of the students, in fact, used to do hard exercises, hard problems, because it's only 20 points. I can still pass and things like that. Unhealthy. Right? Because these are carefully designed exercises, not just random things, but I got to teach 15 problems. No, people have put a lot of thought into picking exactly this sequence of topics, because over a long period, we know that these are things that students will be able to jump, no matter who. Right? I don't buy it. Right? So that again, lots of students don't like me for that. I think. I don't buy into touchy-feely, superficial stuff. Okay, so I'm not going to say you're a programmer or you're doing good stuff if you're not really doing good stuff. Okay, I'm going to tell it to your face, but that's okay, because it doesn't matter to you in the end. What matters is whether you actually understood what the hell was going on, because you don't need me to tell you whether you're a bad programmer, right? You're a good programmer. Even if I do tell you you're a bad programmer, you say, what the hell is he talking about? I know I'm a good programmer. Okay, that's the mindset you want to go to. And in order to get there, in the past, that was much harder for me, because students would just say, all right, I've done all the needful, just give me a grade and I'll go away. And so I spent quite a bit of time trying to figure out a way in which students can't get away, right? So they got to do this, otherwise they're basically, screwed. So I think it worked, because I tried it out in 2019, the first class. I think there were, I forgot I think Java and the CS2A were the first ones I did. And then I did the 2C quests, because I taught 2C after that. And then the quarter after that, I taught 2B. I haven't forgotten the history, I think. I got to think back. And then when, CS55, we just started like first. It's all fun, actually. I'll just keep it running as long as I can. Really, it doesn't cost a lot either. So it's great fun. I think people should make use of it. I think that's why I'm happy for Genius Bootcamp, because I think there's something that can leverage this and actually give students a chance to just do it without looking for validation out there. Just do it and say, I know how to do this now, right? Without having to go to a class. Really, you don't have to attend my class. All you need maybe are just support groups from fellow students. Now, I'll obviously come to those meetings from time to time, because it's fun for me. But that's all you need.
You just need other people who are looking for the same thing as you. Because, you know, when in the power of the group, you just discover one person's solution might be another person's problem, and vice versa. And you discover these, and then when you find a solution to your problem yourself, that will stick to your mind much better than if I were to tell you, right? Because in a lot of courses, that's what they do, right? They just feed you information, and then as long as you just regurgitate the information at the end, you pass. But that wasn't doing anything for my students. And in fact, they do my 2A, and then in my 2B, I would see 2A level errors. And then in my 2C, I would see, lots of students who didn't know the basics. And of course, it's a hard problem to control, really, because you're not the only one teaching. And we have other faculty, and students who come from other colleges who didn't do such a good job of learning, or a teacher who was too slack. Lots of teachers are too slack, even at Foothill. I know, because I've complained many times. I've complained many times to, Vito was a chair in 2019, and I said, I should basically take over and do much, the scheduling in terms of that. But, I was getting a lot of students who didn't measure up to the class. And the only way they would pass is, a reason that does not match their level of competence, saying, I got to let them pass for compassionate reasons. No, I don't believe in passing people for compassionate reasons. I do believe in helping people for compassionate reasons. If you can't make a class, if you don't understand things, what can I do to help you understand it? Right? If you don't have money for a class, maybe I can pay your fees, or I'll talk to someone to get a scholarship. Or if you're stuck, maybe I can send you a Zoom link to participate. Right? So all of those things are accommodations. But I don't believe that a student who says, I'm having challenges, should be cut slack for knowledge, because you're paying for the knowledge. And so I think that is one of the reasons why you may also find bad reviews about my class, because students don't like that. Most students don't like that. They say they don't get any help at all, but that is not true. Okay, ask some of my past students if you can find them, but they actually do get a lot of help, and more from fellow students. Okay, they all help each other, and it's absolutely fantastic. I love the experience, by the way. You guys are having the experience, but I love it because then I get to participate in it from time to time. In fact, these days I watch more. I read your posts on Reddit more than in fact, the last time I watched entertainment was a long time ago. I only watched these short form videos on Facebook for the last, few weeks. Some of these things I've pretty much given up on entertainment mostly, and my major source of entertainment really for many months now is really technical content and interesting stuff, not necessarily technical content, interesting stuff that is produced by people that I know personally. And whether they're my student or someone I've met randomly, right? But if they've done something interesting, that is far more valuable to me as entertainment. Passing than some show or a game that is fleeting and I'll forget, right? Even the best headshots you forget after you've made hundreds of them, right? In Fortnite. So like that. And so yeah, so that's what I like about this class. And I can always, this is the first class, right? But I said this to classes that I've towards the end of the quarter, when I've actually been so super duper happy with the class. They've done a great job and distinguished themselves, every one of them. They've done a great job and also said cool and fantastic things. So I actually thank them. But already I have the sense, right, that you're all, because I can see that many times when students are not interested, they're not really listening to class, they're really watching YouTube or doing something else. Or at least, but you guys all seem to be vetted and listening to and working on these problems, and Isidore came up with this problem. So it's great. You just have to keep at it. And as long as you make time enrolling in other easy courses, this will be probably the best thing you've ever done at this time of your life. All right. So I encourage every one of you to go all the way, right? Even if you're not enrolled in 2B, you should enroll in 2B because Foothill we do need the enrollments. And also we do need the enrollments to keep the good sections going. We have Lane Johnson in our department. He used to be a STEM tutor, but he is one of the few people that I have complete confidence that he knows everything. Like, Chris, he knows, he's done every quest, he knows all the details. Some of the things that I've done in the class are in fact due to feedback from Lane Johnson. So I have a lot of confidence in students that come from Lane. And fortunately, this quarter, only Lane and I are teaching C++. But sometimes we also have some weaker adjunct faculty teaching, and then I am unsure about the quality of students I get in my downstream courses like 2B and 2C, right? But you guys are all in my course. As long as you're doing Lane's course or my course, you should absolutely do, right? The Genius Bootcamp. Even if you're doing Lane's course, because Lane is not going to do questing, pretty sure, right? Because he's just been, joined. So obviously he'll want to develop his own style and materials and so on. So, and Foothill cuts them slack to give them time to develop as all the professional materials. So I don't think he'll be using questing, but even though, right, he'll be able to help you with the question because he's done all of it. He knows how it all works. He can help you. And even though you're doing his section, and I'm pretty sure it'll be rigorous, okay? It'll be just as rigorous as my sections. Even though you're doing that, and the assignments don't match topic to topic, I highly encourage, even if you're doing his section or your friends are doing his section, to do the question on the side, because they're complements, all right? They're either the same or they're going to complement each other. And this is probably the best sequence of classes you can take. Even if you go on to other colleges later on, you'll actually remember this, okay? If you choose the right, any college you go to, if you choose the right classes, right professors and everything, that is an experience that you'll remember until the very last day, and it'll stick with you, right? So, and a lot of students go for the credits and say, all right, I need so many credits, I'm going to pick that class, and then they go to Reddit, the Foothill Reddit, and say, which class can I get an A for no work at all, right? And that gets the highest rating on Rate My Professor, right? And so students gravitate to courses where you can get good grades for no work. That is like saying, I'm going to go to a restaurant and pay them like $500 for a buffet, but I'm not going to eat anything. Right? Because you've come here and you've paid fees. This is, valuable stuff to be, and this is the best time in your life. With the time that you spend now is high value currency, okay? Any time that you have, this time, you can actually suck up knowledge. And the greatest advantage you have right now is as students, you don't have any pressure because you can fail. You have the freedom of failing. Because later on, when you're a professional and all, you still fail, obviously, right? But I think you won't want to fail as much as now. Now you're actually okay with failing, and people want you to fail because you want to fail in as many different ways as possible right now, so that you don't fail later on. So we have an environment where you can fail, at least in programming, okay? Computer science. You program, run into errors. Don't ask someone else to do it for you. Fix it, and then fail. And then later on, you'll find that you'll be advising the next quarters to B students, 2A students. And hey, you should, if you do that, that is the reason. And they post a question and you know the answer without even looking at their code. Right? Look at, on Reddit, everybody's answering everybody's questions without looking at their code. They're just posting a question. Say, I'm getting this error. And someone says, yeah, all right, probably this is what's going on. You should take a look at that, right? So toString is not working, right? So you get I'm so sorry. Okay. You get this view of how programs should behave, right? And that is not something that just comes automatically. It's practice and looking at your code repeatedly, and in different ways, also builds a mental picture of how it will look in other good programmers' computers too. So, and since everybody's growing with you, when they are posing a problem, you already know what the hell is going on without having to do the same things as they did. So all of that is very valuable later on when you, for example, you have to manage software engineers, okay, in your job. And as a manager, you don't have the time or you can't afford to go into the code of every one of your coworkers or your employees. You have to develop an innate understanding of how their code is going to look based on a few samples that you've looked at and the problem description. Yes, because otherwise it's not going to, you've got 20 people on your team. How are you going to look at, even though you have peer code review and all that, if the manager is not sound and they know what is needed and how it should be done, and say, oh, well, your code, okay, it works, but it's not fast enough, right? How do they know it's not fast enough without actually having run a test? But you'll get a sense. After you do this, you'll get a sense. Without having to do it, you'll say, run it and you'll know, all right, so there's something wrong there. And you can go and do it. Now, a lot of people actually resent that. I found that these people don't seem to be doing any work, but they're making a lot of money, right? But they're actually doing a lot of work because, if that same thing, if that person hadn't told you how to do it, you'd be spending 15 months of effort trying to figure out what the hell that was. And that 15 months cost the money that you paid that person, right? But that was real 15 months of effort. But that was not 15 months right then. It was 15 months equivalent then before. It's already stored. Once you've got that in your head, you can reuse that repeatedly. It's like money you can spend, but it doesn't, your bank balance doesn't go out because you've got it in there. But ordinary money made of material things, once you spend it, it's gone. But knowledge you can spend any number of times, but it's still there. And that's why it's different from ordinary book knowledge. Okay, book knowledge, after a while you can't spend it. Okay, it'll get superseded. Something else will be there. But don't stop at book knowledge. The book knowledge is okay to get something done. But if you really need to do it, go inside the book and say, why did they do it that way? Once you understand that, you don't need the book anymore. Because the book is just one way of doing it, but you know how to do it generally. Yeah. So so if you want to just do stacks, I'll show you one way to do it. Course number 8, you're going to be doing stacks one way, right? But there's so many different ways. But I'm not going to say, do a stack in all these different ways. But I'll say do a stack here in this way, but do a queue in that way, right? But when you do a queue that way, you'll know how to do a stack this way too. So you get variety in assignments, not just mine, okay? Even if you do other classes, when you do the assignments, I've seen students who say, I'm not going to follow that course. I'm going to do my own sequence of topics. They're wasting time and they're wasting a lot of good thinking that's already gone into this. Okay? They picked out these topics and they said, do this, okay? It's going to be easiest for you. They say, I'm not going to do easy stuff. I'm going to do hard stuff, okay? So yeah. So these topics, these assignments are designed so that you get different perspectives with variety, not having to do the same thing over and over again. When you get different perspectives, you naturally get a sense for how these things work, and you have a mental idea of the complexity and everything. Okay, and again, in CS2C, when we get to CS2C, we'll just introduce the idea of complexity, running time, big O notation, and polynomial, and how to, and there seems to have a lot of mathematics. Yes, right now, especially some of these people, many people in 2A also have math phobia for no reason. Hey, where the hell is Stanley gone, by the way? He's when he's checked out his bag is here. Okay, so many people have math phobia in 2A level courses, but really, again, it is just what I found is the phobia of anything is really unfamiliarity. Right? People confuse unfamiliarity with phobia and say, oh, I can never get it because I can't get the name, I can't get what's under it. You just have to get over it. Okay, and that comes with practice. So I'm not Beijing. I'm going to talk in Mandarin from tomorrow, right? So it's impossible. But if I live there long enough, fine. Maybe I'll be writing poetry in Chinese in 5 years. Yeah, if you live there long enough and you get exposed to it repeatedly, I find I can do it. So you just have to believe in that and keep at it. And then so this complexity and all these things, they may look very foreign and intractable from here, okay, from 2A, they look, oh my God, never going to go get to that level. But you will, I promise, right? You will be surprised with yourself when you're there. And that is the really cool thing about the posts, okay? But Chris only has posts from CS2B onwards, okay? You didn't post that much when you're doing the blue class, but Namrata has posts all the way from blue. And I got to tell her sometime to go look at your own blue posts from several quarters ago, and now look at the green red poster you're making, right? And you'll be totally flabbergasted with yourself. And that feeling is not something you can buy, or you just have to feel it. You have to feel it. It's experiential, so you can't really convey it, but you will actually feel it. Everyone I know who's gone through that route has felt it, and there's a sense of achievement and saying, now, okay, I don't need a book to do this algorithm because I know this is how it works. And if someone publishes a paper saying, this is, let's say, Rebecca's algorithm, right? Some 10 years later in a journal, right? So all right, this is a new way to do it. So how is that person doing it, right? Because I already know a way to do it, and Rebecca's got a better way to do it. How is this better? You'll never look at how it is better later on if you just didn't understand this first. You say, all right, why is she's got another formula and it's faster, and you'll do it. But if you actually understand this, you'll actually be intrigued enough to look at that publication. Hey, actually, Rebecca, she was in my class and she's got a paper out there in this journal, right? Let me take a look at it and see why it's faster. And so those kinds of things, you'll just get a sense for it. It'll come naturally and automatically without conscious, you got to conscious effort in the sense you just got to press yourself to do it. But that's the only thing you got to do, right? You press yourself and convince yourself to do it. Don't say, I'm going to do it and I'm going to understand it, okay? If the people who say, I'm going to do it, I'm going to understand it, I'm going to conquer it, okay? Well, those people never end up conquering, right? So if you go out with a mindset of, I'm going to conquer, you're never going to conquer. You say, I'm going to go and understand first. I said, Justin or someone posted a note in CS2B. Say, I'm going to learn ways to control AI, okay? So I posted a reply. Say, all right, you're learning to control AI. The first step would be trying to understand AI. And then the second step would be to control it. And then this course, this entire course, blue, red, green, blue, green, red, will prepare you to understand all these things. Once you understand it, you can decide, do I want to control AI? And if so, what are the ways I can do it, right? Maybe you don't want to control AI at all with the models that you are generating, all those things that you'll find out. There's some noise coming from, oh, my phone is here. Okay, so yeah, so those kinds of things, that when you get to know this deep enough, you'll actually start feeling. And I would like to see that in each and every one of you, okay? And also thanks, especially for all the returning students, okay? Stephanie, Simon, Stanley was also, in my class before Chris. A lot of people, right? So that's really cool. So thank you all. And I'm pretty sure that most of you are going to be my returning students too. But I'm not planning to do a in-person 2B and 2C. This is 2B and 2C. They're not really, I don't think they're in-person suited, right? Because you need some social interaction with your peers who are solving problems in 2B and 2C level. But it's not something that you sit there and I say, all right, this is how you create a minimum spanning tree, right? And sort the edges and then pick them off like this. Yeah, okay. But I gotta say, all right, then I would say, why do I do it, right? Why do I pick the edges off in decreasing order of weight? That's a good question, right? But that is not a question for a classroom. Because in a class, I can say, oh, this is a proof. This is a proof why you pick the edges off, and you can prove that this is the best thing you can get. Yeah, okay, that's classroom. But there's no way you can appreciate that in the 2 hours you get here. So that kind of thing in 2B and 2C level concepts, more suited to personal discussion in these forums, where you can actually have these interesting chats with your friends, and then take them away to think about when you're sleeping even, right? Or in the shower. They're just thinking about, this interesting conversation. And you get these ideas. And those are the things that you can take away from these, meetings. So yeah, I'm glad that you guys are setting up these meetings and you set up more of these. I'm happy to set up as many Zooms as necessary. And not everybody needs to make it to every Zoom, but you can try to make it as many as you can. You can talk to your fellow classmates. And if a topic that you are confused about is not being talked about in a Zoom meeting, don't just leave the meeting. I think that you get a much better understanding of the subject, even if you already understand something. Just to listen to other people's problems, right? You don't have to offer a solution even, right? Just listen to other people's problems. Just by listening to what other people are facing, you get a much better understanding of the subject, because it's different perspectives, and that is the power of the group sessions. So do as much of that as possible. It's a 2B and 2C will basically just run mostly like a boot camp, meaning that we'll have, it's a regular course, but it will mostly happen on Zoom catch-up meetings, and of course, Reddit, and one-on-ones with me too. That's fine. We'll record all of the meetings so that it's beneficial to everyone. So we'll do that. But that's it, right? I actually don't have anything to say. Today I didn't actually have anything to say. I just came here saying, all right, if someone had a problem, I'll solve it on the whiteboard. Isidore was the only one. If you other guys have problems, I can try and solve them. Is it time already, by the way? Yes. Holy cow! I've been talking for all this time. Pretty much. Wow, I'm so sorry. Okay, I didn't mean to take up so much of your time, guys. But and thank you, Rebecca. Is this yeah, okay. All right, okay. Let me say bye to online guys. Turn around. Okay. All right. Hey, bye, guys. Thank you all. Okay. So we'll put this up on YouTube.
The solution to that problem,
Oh, this
is it one